Did you know that soils are more than just dirt? They consist of minerals, water, living things, and organic matter. They provide life for us and sustain our environment. They determine plant production, reproduction, and its ability to live, so its mortality. They determine the types of vegetation, the species that live in that area, so kind of the habitats, and it determines the type of livestock we can have, their health, and their production. Soils also determine the quality of water and the availability to us. Soils are incredibly important in supporting all of the systems on our Earth, including the hydrosphere, geosphere, biosphere, and the atmosphere. Soils perform a vital function for us. They provide necessary nutrients for plants to grow and for animals to live below the surface. The earthworm is an example of this. It's an example of this organism that relies on things within the soil like nutrients from decaying plants and animals, and the earthworm also plays an important part in aerating and fertilizing the soil. They are one piece of the cycling nutrient system. Here's a fun fact about earthworms. Did you know that earthworms surface after rain not because they're afraid of drowning, but because there's enough relative humidity to keep them from drying out? Soils really are an essential piece in the water cycle for providing that filtered and detoxified fresh water to drink, as well as providing enough water and nutrients for those plants to grow, which eventually sustain us. Another factor is soil is what everything is built on. Without soils, we have nowhere to put our houses, nowhere to build our roads and drive our cars. They're really essential to our lives. The living systems that occur above and below the surface really determine the properties of those soils. So they're determining how much nutrients are in the soil, how much water filters through those soils, and how clean that water is. They also determine how fast of decaying rates those leaves break down and provide those nutrients down back into the soil. They provide the minerals and elements that those plants need. So soils are incredibly important. They also support life. So it's these tiny little things like bacteria and fungi and protozoa and nematodes and arthropods and earthworms that really rely on soil. Without the soil, these organisms wouldn't be able to live. And without the organisms, our soil wouldn't be able to develop and provide those nutrients and the great water that we get from them. So they're really beneficial. They're decomposing all of the materials. They're releasing nutrients back into the soil. They're creating those pores like the earthworm. It eats the dirt and then it poops it back out. It fertilizes it and it stabilizes the soils. So soil quality is really important. And it's important to understand how we measure soil quality. We need to know the amount of nutrients that are available, what the erosional impacts are, the availability of the water to the area, the ability of those soils to filter the amount of water through and make sure that it's high quality water. And we can do that by doing a bunch of tests. We can test the pH, we can look at the soil textures, we can look at the nutrients that are in the soil. All of the soils are unique in their chemical, their physical, and their biological properties. And these are important to understand. We need to look at the color, the texture, the structure, the consistency of the soil. Is it clumped? Is it really separated and lots of particles just kind of roaming around? Are there roots holding it together? Are there pores? What are the features of the soil? So it's really this natural body of these solids and liquids and gases that are really interacting to help support those rooted plants. And this is called the study of soil, so the pathology of soil. There are 5 soil forming factors. There's climate, there's living organisms, there's parent material, there's topography, and there's time. I call this the chlorpt. And sometimes when we talk about topography, we talk about relief. So we call that chlorpt. Now, all of these things play important factors in your soil. The parent material, what kind of rock did the soil come from? What's the climate like? Is it a really tropical climate where things break down very quickly and nutrients is able to be added back into the soil very quickly? Are there lots of living organisms, lots of bacteria breaking down those plants and materials? What's the topography like? Are we in a mountainous area? Are we in the plains, the valleys? Where are we at and how does that affect our soil formation? And time. Has it been a short amount of time that this soil has had time to develop? Or do we have long periods? And we can tell that by looking at how thick those layers of soil are. So soils do have limitations that we as humans must understand. And these are kind of concerns for life in our properties. So allergies, corrosivity, meaning like, is it gonna rust? Is there a lot of dust? If there aren't plants holding down those materials, are we gonna have a lot of dust flying through the air? Like an opportunity, they have to make sure that when they were working in the area that they were reclamating, that they had water trucks just going through there all the time because the dust was just horrible and the wind would blow it. And so they had to make sure that they kept that down. Same thing with the hill by the slag pile as you go into Anaconda, the grassy hill. That used to be just a big pile of dirt, and my mom used to tell me that the winds would whip those across the highway and you could barely see anything. So they have added plants to that pile to make sure that dust and that dirt stays down. If we think about how soils and water interact, flooding is an issue, piping, rapid runoff, sand blowing. Going back to the rapid runoff, we have to think about that, especially in Deer Lodge during the spring. We have these creeks that run through town, and then we have a large amount of snowfall, and then we have that melt. Where is that going to go? Sinkholes are a big deal in Butte because a lot of Butte underneath the ground are all of these mine tunnels. So you read a lot of the times in the newspaper articles about sinkholes. Then we also have to worry about water tables. Like in Opportunity, the water table is really, really high. It's actually 2.5 inches from the surface. So we can't have basements. There's contaminants all around us. We live in a national Superfund site. And then crop loss, erosion, all of those different things we have to think about. So soil is really incredibly important, and how we take care of it is important. So we do have scientific names for soils. We have them classified. There's a soil taxonomy, and all of those are listed here if you would like to take a look at those. So why is soil science important, and where can it be usefully incorporated into our studies? So in science, we can talk about ecology, because in ecology, we're focusing on the animals, the ecosystem, everything that plays into that. And that includes the soil. Same with biology and chemistry. And then in earth science, of course. We could also talk about social studies if we include world trade and land use. So what are we using our range for? How have we used that in the past? An example would be the Dust Bowl. And then mathematics, so soil loss over a certain amount of area. Like, how can we reduce that? History, settlement of the U.S. and the Dust Bowl. And in art, soil is in crayons and acrylic paints. So soil, even though you might think it's just dirt, it really isn't. It is kind of the basis or the foundation of everything, including organisms and plants that really keep all of our systems moving. And when I say systems, I'm talking about those 4 systems: the hydrosphere, the geosphere, the atmosphere, and the biosphere. All of those are interacting with one another, and soil is a big part of that.